Now, I love these ones because they look more complicated than they realistically are. I have an entire fraction being divided by another entire fraction, which means that I can start by rewriting that I'm taking the numerator, which is a full fraction, 4x plus 2 over 3x plus 12, and I am dividing that by 3x squared plus 9x over x plus 4 squared. The next thing that I'm going to do is I'm going to factor everything that I can. And I can actually factor all three of these. And this one I'm just going to write out what the two factors are because it is squared. So I'm going to state that I have 2x plus 1 over 3x plus 3 divided by 3x x plus 3 over x plus 4 times x plus 4. And sorry, there's a little mistake here. This should have been 12, which means that this is going to be 4 and x plus 3. And on the bottom, it should have been divided by 3, so that should have been an x plus 4. Sorry about that. Now I'm going to check for all of my different non-permissibles through it all here. I know that I have some repetitions. I'm going to take the reciprocal of what comes after the divide, 4x plus 3 over 3x plus 4 multiplied by x plus 4 times x plus 4 over 3x and x plus 3. I'm going to cancel out an x plus 3 and an x plus 3, cancel out an x plus 4 and an x plus 4, and what I'm left with is 4x plus 4 over, on the bottom, 3 times 3 is going to give me 9x, where x cannot equal negative 4, 0, or negative 3. When I get to example 5, same process. I'm going to have to factor down. In this case, I'm going to factor everything to find my non-permissibles. And then from my non-permissibles, I'm going to simplify. So I'm going to factor down the first one, and I'm going to get 4x and x minus 3. In the denominator, I have a difference of squares, x plus 3, x minus 3. I'm going to divide that by 7x squared and x plus 1. And in the denominator, I get x plus 1 and x plus 3. Now don't forget to check, and if you need to make a list for all of your non-permissibles, you can. So I can see that x cannot equal positive or negative 3, negative 1, or 0. And before I even flip here, I can actually start canceling out. X minus 3, x minus 3, x plus 1, x plus 1. These ones can actually already be reduced. I'm going to take the reciprocal, 4x over x plus 3, multiplied by x plus 3 over 7x squared. And I'm going to cancel out an x plus 3 and x plus 3, take away the x from here, and be left with a singular x there. And I can say that this all simplifies to 4 over 7x, where x cannot equal positive or negative 3, negative 1, or 0. Taking a look at example B here, I see that I can simplify the numerators and denominators across here, remembering that all of this comes after the divide symbol, so when I'm looking for my restrictions, I have to look at all the denominator and all the numerator here. I can also see that this is in the wrong order, so I'm probably going to fix that right from the get-go by changing the order and taking out a negative. So when I'm factoring this down, I'm going to divide the top by 10m and be left with 2m plus 3. On the bottom, I'm going to pull out the negative and be left with 4m squared minus 9, which is actually different squares, 2m plus 3, and 2m minus 3. I'm going to divide that by, when I factor down what's in here, on the top, I'm going to pull out an 11m, and that leaves me with m squared minus 1, or m plus 1, m minus 1. I'm going to use decomposition in the denominator to factor it down to 2m minus 3 and m plus 1. And I'm going to multiply that by, these can't be factored down, 2m plus 3 and m minus 1. Now, when I am doing this, remembering that I am checking for all my non-permissibles throughout all of here, I'm going to make a quick list of all the different ones that exist. I know that m cannot equal positive or negative 3 over 2. It can't equal positive or negative 1, and it can't equal 0. The 0 is the one that you're most likely to miss from that m that exists right there. Next, I'm going to start canceling out. Take away 2m plus 3 and 2m plus 3. Take away an m plus 1 and m plus 1. Take away an m minus 1 and an m minus 1. And what am I left with? I have 10m over 2m minus 3. And when I take the reciprocal of what's in the brackets here, the numerators are going to go to the denominator. So I have 11m and 2m plus 3. And in the denominator, I was just left with that 2m minus 3. I can continue to cancel out, take away an m from here and an m from here, take away 2m minus 3 and 2m minus 3, and all I'm left with is 10 over 11 2m plus 3's. And this is true so long as m cannot equal positive or negative 3 over 2, positive or negative 1, or 0.